Yeah, Science Tech Daily. Breakthrough for SHIELD team studying our solar system protective magnetic force field. Astrophysicists on BU's NASA-funded SHIELD team reach another milestone on their quest to understand the heliosphere. A multi-institutional team of astrophysicists headquartered at Boston University, led by BU astrophysicist Merov Offner, has made a breakthrough discovery in our understanding of the cosmic forces that shape the protective bubble surrounding our solar system. Yeah, this is an interesting sentence. Cosmic forces that shape. So they assume that the energy is probably coming from outside. Somehow it seems that they think like that. Which would indicate that there would be no nuclear reaction happening in the sun. This is what it probably means. I don't know, they just don't tell you. A bubble that shelters life on Earth and is known by space researchers as the heliosphere. I guess everybody else who knows about that, it doesn't have to be a space researcher who knows that it's the name of that thing. Like a dog is a dog. If you're like a dog owner or not, it's still a dog. Astrophysicists believe the heliosphere protects the planets within our solar system from powerful radiation emanating from supernovas to final explosions of dying stars throughout the universe. Or current novas, or like all those novas they have found yet. They believe the heliosphere extends far beyond our solar system, but despite the massive buffer against cosmic radiation that the heliosphere provides Earth life forms, no one really knows the shape of the heliosphere or, for that matter, the size of it. How is this relevant for society? The bubble that surrounds us, produced by the sun. Now again, they talk against them oneself. Offers protection from galactic cosmic rays, and the shape of it can affect how those rays get into the heliosphere, says James Drake. There's a lot of theories, but of course, the way the galactic cosmic rays can get in can be impacted by the structure of the heliosphere. Does it have wrinkles and folds and that sort of thing? Offer's team has constructed some of the most compelling computer simulations of the heliosphere based on models built on observable data and theoretical astrophysics. But at BU, at the Center of Space Physics, over a College of Arts and Science professor of astronomy leads a NASA Drive Diversity Realize Integrate Venture Educate Science Center that's supported by 1.3 million in NASA funding. That team, made up of experts often recruited from 11 other universities and research institutes, develops predictive models of the heliosphere in an effort the team calls SHIELD, Solar Wind with Hydrogen Ion Exchange and Large Scale Dynamics. This is how our heliosphere looks like, according to them. I really don't understand somehow how they are watching at that, how to understand that picture. Is this what the heliosphere looks like? BU-led research suggests so. The size and shape of the magnetic force field that protects our solar system from deadly cosmic rays has long been debated by astrophysicists. Since BU's NASA Drive Center first received funding in 2019, Olfer's SHIELD team has hunted for answers to several puzzling questions. What is the overall structure of the heliosphere? How do its ionized particles evolve and affect heliospheric processes? How does the heliosphere interact and influence the stellar medium? the matter and radiation that exists between stars, and how do cosmic rays get filtered by or transported through the heliosphere. SHIELD combines theory, modeling, and observations to build comprehensive models, Offer says. All these different components work together to help understand the pulses of the heliosphere. And now, the paper published by Ofer and collaborators in Astrophysical Journal reveals that neutral hydrogen particles streaming from outside our solar system most likely play a crucial role in the way our heliosphere takes shape. In their latest study, Ofer's team wanted to understand why heliospheric jets blooming columns of energy and matter that are similar to other types of cosmic jets found throughout the universe become unstable. Why do stars and black holes? There are no black holes. And our sun eject unstable jets, Ofer says. We see these jets projecting as irregular columns, and astrophysicists have been wondering for years why these shapes present instabilities. So instabilities are patterns as well. Just saying. So, similarly, SHIELD models predict that the heliosphere. This is also interesting. Astrophysicists have been wondering for years. Now, let's make it a bit better. That's really sketchy. Astrophysicists have been wondering for years why these shapes present instabilities. Similarly, SHIELD models predict. That's an oxymoron. How can someone who's wondering predict anything? But let's continue reading. Predicts that the heliosphere traveling in tandem with our sun. No, it doesn't. It's a part of the sun. It's spheres in spheres within spheres within spheres within spheres. It's a part of the sun. It's not traveling with it. And encompassing all our solar system doesn't appear to be stable. Other models of the heliosphere developed by other astrophysicists tend to depict the heliosphere as having a comet-like shape with a jet or tail streaming in its wake. In contrast, Ofer's model suggests the heliosphere is shaped more like a croissant or even a donut. The reason for that, neutral hydrogen particles, so-called, because they have equal amounts of positive and negative charge to net charge at all, they come streaming through the solar system, Ofer says. Yeah, but not randomly. Using a computational model like a recipe to test the effect of neutrals on the shape of the heliosphere. She took one ingredient out of the cake, the neutrals, and noticed that the jets coming from the sun shaping the heliosphere become super stable. When I put them back in, things start bending, the center axis starts wiggling, and that means that something inside the heliosphere jets is becoming very unstable. So is there a possibility that there are no neutrals? Instability like that would theoretically cause disturbance in the solar winds and jets emanating from our sun, causing the heliosphere to split in its shape into a croissant-like form. Although astrophysicists haven't yet developed ways to observe the actual shape of the heliosphere, Ofer's model suggests the presence of neutrals slamming into our solar system would make it impossible for the heliosphere to flow uniformly like a shooting comet. And one thing is for sure, neutrals are definitely pelting their way through space. Yeah, maybe. But you can read the rest if you want to. I want to show you some things, what I thought about when I was reading this article. Let's hop over to people who should know how it works. NASA, this is Earth. Can we get a better picture of that? Yeah, here. No, it's the same size. Sorry for that. Too small screen. But anyway, this is Earth, South Pole, North Pole. Doesn't matter actually. But anyway, there's energy coming in and energy going out, which is creating those field lines. It's like a bar magnet, okay? Because it has poles. Now, Wikipedia. The sun. The sun is a star at the center of the solar system. It is nearly a perfect ball of hot plasma. This is the North Pole of the sun. This is the South Pole of the sun. This is the equator of the sun. So there is energy going in and energy going out, which creates the lines. In this case, the lines are so big, or lines, it's a sphere. There are spheres and not only lines. So we are inside this Earth, which with its own little things around it, like the other planets have. And we are connected through the interplanetary magnetic field lines, which I think they go like that. They don't go between, like from equator to equator. I don't think it works like that because we have the BIRKELAND currents, which go through the planetary bodies or star bodies. So if we watch at the CME tracker, which is this thing here, here they have just this one line, the interplanetary magnetic field line. But I think it should be more like that. And they might be maybe shaped like that because of the pressure. But I don't think there's a line in the middle from equator to equator. Somehow doesn't make sense to me. But anyway, if we find the article, wrong browser. Where's the picture? This. Somehow it seems to me that this is basically going from the equator to the equator. I don't know. I don't know how to understand that picture. Maybe these lines, they should go more here, like in the center, if that's some kind of center, I don't know. So those should go in here, and this is splitting the up sphere. You know? Not like here, slamming into it. Because we have a BIRKELAND current after all. But I leave it here. I could make like hour-long videos about that, trying to explain. But I might be wrong after all, I don't know. But this doesn't make sense to me. this picture from NASA. Magnetic force field. They just don't want to admit that the electric universe theory, Talbot, Thornhill, Hall, and all the other dudes from Sapphire Project, all those, Velikovsky, they were so much more right, or are right, because they can predict, prove, and show you. But I'll leave it here. Thanks. Bye.